Hello, I'm so glad that you are here with me to explore and think. So let us have fun together. Are you able to hear me? Now just tell me, when you hear the word mathematics, what comes to your mind? Is it fear, formulae, marks, getting the solution correct, or all of them? But today it is going to be different. We are going to emphasize on mathematical thinking, so we will not need any pen, paper, or even formula. So, are you ready to just think with me and explore what is mathematical thinking? Now, let me tell you one thing, that in the beginning, for the first 15-20 minutes, you may feel that everything is totally disconnected. But that is fine. Just stay with me, and you will find that slowly everything falls into place, and we see a perfect pattern that will help you to think mathematically, and a whole new arena will open up. So just let us start. I have this two glasses. One contains water and the other contains milk. And the volume of both of them are the same. Now what I do, I take a spoonful of milk from the milk jug and put it in the water.
Wait 1 minute. The audio and video is lagging, so give me 1 minute. You say this. Say this.
So I take a,
Audio and video is lagging, so give me 1 minute.
the audio and video is lagging, so just give me a minute. इसको चेंज कर दो.
You can continue to speak.
So what I had done is I had taken equal amounts of water and milk, and I took a spoonful of milk from the milk glass, put it in the water glass and stirred it. Now I take the same spoonful of the mixture and put it in the milk glass. Now my question is, does the water glass contain more milk, or the milk glass contains more water, or they are equal? So just let me know. Does the water glass contain more milk, or the milk glass contains more water, or both are the same? What do you think? So you may want to do calculations, use formulae, and think. So what do you feel is going to happen? Now actually, if you see, the volume of the liquid in the beginning and the end is the same. Whatever volume was of the milk glass, the same volume remains. Whatever was of the water, the same volume remains. Though we had transferred, but we transferred the same volume. So, what does it tell you? That since the start and finish volume are the same, each of them will be the same. That means the water glass will have as much milk as the milk glass has water. Isn't that quite interesting? We did not really need any calculations. We looked at something which was not changing. Now, supposing I change my water glass and I take a glass which is bigger in volume. So, initially, my water is more and the milk is less. It doesn't matter. We will do the same experiment. So, I take 1 spoon of milk and put it in the water glass. I stir it. And then I take the same spoon of the mixture and put it in the milk glass. Now the question is the same. Does the water contain more milk, or the milk contains more water, or both are the same? Again, perhaps you will say that since the volume here was more, so this would contain, this one, the milk one will contain less water. But look at something which is not changing. What did we do? We transferred the same amount. We took this spoon, and the same volume was transferred from here to here. So the beginning volume of the milk glass remains the same. The beginning and the end volume of the milk glass is the same, and the beginning and the end volume of the water glass is also the same. The composition is changing, but the volumes are remaining the same. So both will have the same amount. That means the water glass will have as much milk as the milk glass has water, even though the volumes with which we started is different. So, isn't this quite interesting? We did not do any calculations. We just looked at something which is not changing. What was not changing? The volume that we transferred was not changing, and therefore, what the start and end volume of each of the glasses is the same. Okay, now let me come to another type of puzzle. I have these 12 coins here, and a move means flipping a coin. Now, this coin has two sides. On one side, a number is written, the other side is plain. So, the side on which the number is written, we will call it head, and the plain side, we will call it tails. So, I have these 12 coins, and I have 4 heads up. Now, I want to know in how many moves can you make 0 heads up? Remember, a move is flipping 2 coins. So just see, you have to make moves as many as you like, but you want 0 heads up. That means no head should be up. On the top, there should be all tails up, so all. So what do you think it is? If I take a move and I flip, so one move will reduce the number of heads by 2, and I have here 2. So if I make another move, again, those also have become tails. So in 2 moves, this is possible, right? Now let me have this, that in the beginning, instead of 4 heads up, I have 5 heads. So in how many moves can you have 0 heads up? How many moves should we do so that there are 0 heads up? So let us see. I will do one move.
Tell them they can write in comments. Tell them they can write in comments.
Right? So you can keep on trying and see. I had these 5 heads up. You have to make moves so that there are 0 heads up. So just see how will we be able to do that. When there were 4 heads up, we were able to do it in 2 moves. Now there is 5 heads up. So just see how is this possible. Now, if I make a move, I will have 3 heads up. I make another move, so I have 1 head up. I make another move, still I have 1 head up. I want this also to be turned, so I'll turn. Again, there is 1 head up. Again, I do it, 1 head up. Again, I do it, 1 head up. So this is not happening. Why is this so? Let us just think about it. Why is this happening? See, what happens when we take a move? Let us see how do the heads change. When we make a move, how do the heads change? Supposing both are heads, and when we make a move, both becomes tails. So the number of heads has reduced by 2. Now, if we take both tails, then we flip, the number of heads has increased by 2, right? Now, if we take a head and a tail, then when we flip, we make a move, the number of heads is still 1 and tail is still 1. So the number of heads don't change. So what happens? By a move, there is a change in the number of heads. It is either increased by 2 or it is decreased by 2 or there is no change. So, when we had an even number, we decreased the number of heads by 2 by 1 move and then increased. The final result, we again got a even number, which is 0. But when we had odd number of heads up, then what happens? When you decrease or increase it by 2, it still remains odd. So at most what can happen is you will be able to get 1 head up. You cannot get 0 heads up. So it's the parity of the number of heads which is coming into play. The parity of the heads does not change. If initially the number of heads up is even, it will always remain even. If it is odd, it will always remain odd, because from a odd number you subtract even numbers, it will remain odd. And another thing you can see, we took 12 coins. It doesn't matter. The number of coins doesn't matter. Why I took 12 is so as to enable you to start thinking, so that you don't get confused that how many coins should we take. You can have any number of coins. What is important is the number of heads which are up, the parity of the number of heads which are up in the beginning. So this becomes so interesting. So let us look. Are you able to hear me? Now let us look at these two puzzles together. So I have this puzzle. This was the milk water puzzle. What changed? What was changing here? It was the composition. Composition of the solution. That was changing. And what stayed same? What was same? It was the initial
Just hold it from behind so that people can see what she's writing.
initial and final volume of the glasses, of the liquids, in each of them. That remained the same. Composition changed, but the initial and final volume remained the same. Why? Because we transferred the same volume, right? So now let us take the coin puzzle. What was changing? The arrangement. The arrangement of the coins was changing, but what was the same? The parity. The parity of the heads was the same. That means, were the heads even, the number of heads was even, or it was odd. So this shows us something very interesting. What do we have to concentrate on? We have to concentrate on what remains the same. You know, there'll be a lot of things which are changing. It will create a lot of chaos. But in mathematical thinking, what do? We just concentrate on what is not changing. If we can find that what is not changing, that is the crux of the whole solution. So here we found that the initial and final volume was the same. The volume was not changing. And in the coin puzzle, we found that the parity of the heads was not changing. So basically, they are the same things. It's the same idea that we are talking about. And this, in mathematics, mathematicians call it invariance. Invariance is something which does not change. So if in a problem we can find out that what is not changing, that becomes very good. And that makes it easy to solve the problem. So what you can do is, you can see when you have problems, is there something which is not changing? Can I bank on that and then find the solution? That will help you a lot. So are there any questions? You can write your comments in the chat. The chat is open. So mathematicians use this concept of invariance in solving problems. This concept of invariance is used in day-to-day life. So many times you will see that there is a lot of chaos, there is a lot of confusion, everything is changing. But there is one thing which is not changing. And if you can spot that thing which is not changing, that is fine. So thank you for joining me and thinking and learning and being here and exploring things with me. I hope you have found this useful, and today you can just look at life in a different way, spot the things which are not changing, which are invariant. Thank you.